All right, today I'll take you to another option. Let's say we have 192.168.100.0/24. Let's assume that I want this block on one side of the router for some number of users. So I'm going to ask one by one today. So you just have to wait for your turn. Okay, so let's say this block is for 55 users. Over on this side, let's say this is another couple of users. Let's say this is 15 users. And on this side, I'll keep 5 users or something. Okay. So I hope you got the clarity. What is the requirement? So this is 5 users. This is 55 users. This is 15 users. And this is 5 users. And this is the network given to us. If someone wants, they can give you, this sort of thing as well. They can give you this network. They can ask you to configure this on this. They can ask you to configure this on this. Is this right? Aditya, is this right?
Yes, sir.
Okay, it is right. But what is the delimitation of this?
Mm.
What would be the delimitation of this?
Sir, they don't. They will gonna talk with each other.
No, you said it's good. So even I say it's good. But then what is the delimitation?
Sir, if a switch will go down, then they will not gonna talk with each other.
No. I mean, I'm not talking about design. I'm talking about the network 1/0/24, 5/0/24, and 15/24.
Okay.
What do you think? Christo, Lavanya, Bharat, Sudhakar?
Yeah, you can actually see, I mean, like, irrespective of whether how you divide this subnet, I mean, like, you're still getting 55 users only, but you are going to waste for the other 5 users, you are going to waste the IPs.
Yes, that's what I wanted to ask, understand. Okay. So we are actually wasting some IPs here. Correct? Technically, it is right. You can have the reachability between different users, but that is why I put some condition. There are 55 users, 15 users, and 5 users. But I also assigned the block like, right? which is gonna have 254 usable IP. But how many you wanted? You wanted only this. So you're wasting so many IPs. That same thing happens over here. You're wasting it. And over here, if you need only 55, but you're receiving 254. So basically, you're also wasting another close to 200 IP. Okay, so this is why we try to do subnet. So in this case, instead of using different IPs, what I'll do is I'll use this, but then I will make a use of subnet. All right, so let's prepare for first block. So I'll ask Lavanya. So Lavanya, are you ready?
Yes, sir.
Okay, so let's assume I need 55 users.
Okay, sir.
This is the subnet. This is the IP, let's assume.
Okay.
So tell me which block will it fall to? Let me also help you with the table, 2 to the power table,
Yes,
so
sir.
that you can easily guide me. So which table it will fall from this list?
2 to the power 6.
Okay. So I'll take 2 to the power 6,
Yes,
which
sir.
is which is nothing but 64,
64.
right?
Yes,
Correct. So in that 64, if you remove the first and the last, you are
sir.
left with
62 will be.
you are left with 62
62.
usable IPs.
Yes, sir.
Okay, then what we do next step? Once you have the block, how do you find the subnet mask? With what we subtract?
255 dot.
You need to know this is an example for class C.
Yes, sir.
So this is where you will do the subtraction, the last bit, which has a lowest 0 and highest 255. So together they are 256. And when you subtract with 64, you get 192.
192. Yes.
So from here you will construct 255, 255, 255, and 192.
92. Yes, sir.
Okay. And after that, once you have this subnet, you have to convert it into binary.
Binary. Yes.
Okay. So 255 is written all in a 1 bit. 255 is written in all the 8 in a ones, and then this is ones, and the left out is 192, which you have to calculate using 2 to the power 0, 1, 2, 3, 4, 5, 6, 7, which is nothing but 128,
8 plus
Yeah.
64.
64, 32, 16, 8, 4, 2, 1.
Yes.
Right? So how many we get?
So that will be 128 plus 64.
Yeah. So how many CIDRs we get it from that?
2. And 11000.
Yeah. So what is the CIDR value? 26.
26.
Okay,
Yes.
because here we have 8, here we have 8, here we have 8, which is 24, and here we have 2, which is 26. Okay. So now when you create your IP block 192.168.100.0/26 till 192.168.100.63/26. This is the first block.
Yes, sir.
Okay. All right. So thanks, Lavanya. Now I'll ask someone who can help me with the configuration of this. Okay, Bharat, you there? Bharat, you there? Or Christo?
Yes, yes, I'm aware.
Okay. So I will ask you one by one. You just try to help me with the command line. Okay.
Sure.
All right. So what mode is this?
This is uh, privilege. No,
Sorry.
let's say user mode.
Yeah. User privilege mode, which
Yes,
is used only to take the running config, but I cannot
yes,
config do any configuration. So if I have to configure, then what I need to do?
config terminal.
Yes, configure terminal. I'll get into that mode. If I have to change the host name, then
Host name
okay,
space the name.
name of that. Okay, let's assume that now we have figured out the block. So my block over here is 0 to 192.168 1.63/26. So you help me to configure one IP here. So how do I, which interface I should configure? I have 0/1, 0/2, 0/3.
Yeah, let me see the diagram. Because I'm driving also, so
Oh,
can
okay,
I
okay, okay. No, if that is the case, then I'll give it to someone else. Bharat, can you
No,
help me?
it's okay. We are in big traffic, no problem.
Okay.
It's if it is fast to the net 0, then interface fast to the net 0/1.
Okay. So in this case, it is gig Ethernet 0/0.
Oh yes.
Okay. Okay. What else we do? Basic commands here.
Then we will see IP and what the IP we need to set here.
Okay.
And then space subnet mask.
Okay. Let's say 192.168.1 dot. Okay. So which IP can I set in this?
192.168 1.63.
Can I set 63?
Uh, we are setting the IP here, right? The new IP.
Yes, but
Both
63 can I
settings.
set?
No. Yes, you cannot.
Because that
We
is the
are
last IP of that
yes,
network, right?
correct. Yes, it's broadcast.
Yes. So broadcast IP and the network ID don't set it. You have
Correct.
option to set anything from .1 till 62.62.
62.
Okay.
Correct.
So let me
Yes.
pick any random number .25. This is 192 series. What else then I do on the interface?
Mm,
Okay, let me show you the status of this interface.
yes.
Okay, now, okay, so Christo, thanks for your contribution. I'll ask someone else. Okay,
Yeah.
focus
Sure.
on your driving. I don't want to disturb. Okay, all right, Aditya, to you now. Is this good output?
No, sir, we have to go the config terminal and then write the no shutdown
Okay, so gig
to
0/0, no shutdown.
no, sir.
Okay. Is that then good, or are we still missing? Or I mean, uh, I mean, not cosmetic things. I mean, functional wise, it is okay, or something I can do. Or
Sir, write memory is left, I guess.
okay, write memory. Anything else? From here, what do we understand?
So our status is up, then we can ping with another switch or PC
Okay.
description. Sir, I
Yeah.
guess.
But
Like
do we really need description for the interface to work, or is just a cosmetic thing.
Sir, I guess description is the mandatory thing to be like if someone is going to see our interface, then it will gonna know where the connection is going on from which interface is that, and like something
Okay.
that.
See, there are always two types of configs that you can have it. One, I can say mandatory, which will bring up the interface, which will process the packet. The second one is the cosmetic. So whatever we did here, like no shutdown, IP addressing, they're all mandatory commands, very mandatory, because if you don't put them, the interface will not come up. Cosmetics could be like description is a cosmetic. In case you're coming up with a QoS later on, quality of service, or whatever other things you want to tweak it or process, or any syslog servers you want to keep. So they are all optional things. They might or may not be present, but what is present, this is present, this needs to be present, whereas rest can depend upon your requirement. Okay, so
Okay, sir.
I'll go here. As I told, I will put the description just for the cosmetic. We can just say that it's a AT&T 1 Mbps circuit, and connecting India to UK or whatever it is. Okay, and then what do we do? Write mem. Okay, now I'll ask Sudhakar. So Sudhakar, if I have to see,
Sorry.
Yeah, I'm not familiar. I'm still
no,
not
but
familiar with
yeah,
this
yeah, no issue,
command, but
no
I'll
issue.
try.
Yeah, just try. If I want to see the config inside any interface, let's say gig 0/0, how would I see them? Let's say now we have configured something. You are in your network, some troubleshooting ticket has come to you. You have to check whether that configuration is present or not. So how would you check the configuration is present or not?
Okay, I'll try show config.
No, show config will not work. Have you heard about show running?
No.
Show running configuration will give you the complete output of a router. But the problem is you have to scroll. Say, for example, here, I can see the complete configure of what we did, but problem was I have to scroll. And when you have lot of access list, QoS, syslog servers, the config also becomes to, scrollable purpose where you have to go. And so what you can do is, for interfaces, this is the best command. You can do this: show running config interface gig ethernet 0/0. So it will only fetch you that particular interface. So it will show you that you configured description, you configured IP address, you configured no shutdown, and rest of them are the operating system, because these are something which is required. Okay, the duplex auto is nothing but the negotiation between this interface and the connected device or something. If you keep
Okay.
them non-duplex, basically what happens, see, duplex, I'll tell you basically what it is. In the networking world, let's say if one network device is sending something, the next person will just wait until that person has finished it, and then it will use that transmission medium to send it. So that time this guy is gonna wait it. So in the case of duplex, what happens, you can send and you can receive at the same time, which makes networking faster. In millisecond you can finish your data transfer. So these are something which are required. So the operating system, the Cisco operating system itself will put few things by default enabled: duplex auto, speed auto. You don't want to negotiate, but if in case you want to, you can also change these settings. So let's say if I have to change the settings, I go to gig 0/0 duplex question mark. See, auto in the sense, if my neighbor is also a modern device and he's agreeing to have the auto negotiation or auto configuration. So both will negotiate and form it. Full in the sense both will communicate. Half in the sense only one will communicate. We don't use half nowadays. It's a older technology. So you will see duplex auto. Same way, if you want to change speed, you can also restrict your bandwidth of this particular thing. You can make this interface to work on 1000 Mbps or 100 or 10, but we will keep it auto because I want to keep my device at a maximum potential. And the neighbor, let's say if he is running on lesser or a higher, depending upon that, we can auto negotiate it. So these are some additional things, but we don't need to do it. It's already done in the software. So this is how we will check the running configuration. Okay. All right. So this is done. Switch we are keeping in a VLAN 1. Let me configure PC 1 now. So I'll go back to Bharat. Bharat is silent. So Bharat, tell me which IP should I take it to configure on the PC? Just tell me the IP. The config line I'll handle it. Tell me the IP. Can I enter, let's say 192.168.1.100? Can I put this? Bharat, are you there?
So, but in the previous session, I have one doubt. This
Yeah.
one, when if we are communicating a Cisco switch with some other vendor, some like Cisco or Huawei, something which we connected, if auto negotiation is not enabled from the command line, how we will understand this will be the issue while we do the troubleshooting?
You get the drops.
We get
When you go,
drops like the dot.
yes. Say for example, when you do the show interface gig 0/, I showed you the errors that on the interface, right?
Yeah.
So you will start them increasing. You will start the packets getting dropped. So in that case, you have to check what is the config on your side. And for some reason, let's say speed is 10, duplex is half, which can be the reason for the packets getting dropped.
Okay.
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 All right. I'll ask this to Aditya. I don't see Bharat answering. So yeah, Aditya, can I make use of .100 here?
No, sir, because we have to write between 1 to 162. 1 to
Okay.
62 only.
Okay. So what will happen if I try to enter this? It will
Sir,
give me
invalid,
yeah.
yeah, not in a subnet.
Yes, not in the same subnet. Okay. So I have to give within .1 to .62. Let's say I give 62. Will it take? Yeah, it will take. Okay. Now, ping is a protocol to test if the destination is reachable or not. So from this device, okay, from this device, if I try to ping this PC 192.168.1.62, enter, see, it is reachable. Do you see the exclamation mark? That means you're successfully able to ping this guy. Your ping consists of two components, request and response. Router will send the request, PC will respond back. How do we check that? So there is something called Wireshark. Have you guys ever heard about the term Wireshark?
Yes, sir. It is a packet analyzer tool.
Yes. So let's see the packet analyzer tool. Okay, I think I have to put this in the back end. All right, I'll get this done next time. Okay, I'll show you next time. Okay, so I think there is the Wireshark which has to be, and backend people will do that. All right, so if I try to run many more packets, repeat 25. See, now it's a huge exclamation mark. That means it's in a range and they can talk to each other. So similar way, let me give a IP to the PC 192.168.1 dot let's say 35 some whatever in a block 192.168.168 1.15 or whatever. Okay. So now this 35 I'll try to ping. See, now we are able to. So any question while you make the subnet? Good, right? Okay. Now, next block, let's work. Now let's work on the second block. So for the second block, so second block, we will start from 192.168.1.64. Now we have to, how many users are they? 15 users. So which table does fit over there? Which table do it fit?
Two key power 4.
There can be one problem.
2 to the power 5, sir.
Yes. What will happen if you go with this?
So that this will be removed, right? So it will be less.
Yes. So network ID and the broadcast ID, if you take, then you only are left with 14 usable ID. Okay. Yeah, but you need 15 users. So we will go with the next block. So here, if you remove the first and the last, you still have 30 usable IPs, which can accumulate 15. Okay. Now we need to find the subnet. We need to find the subnet mask. So with what I will subtract it? 256 minus
32.
Yes. So what it is? 4.
224.
224. Okay. So 255, 255, 255, 224 is the mask. This is the mask. Now, if I try to elaborate each octet using the ones, 1, 2, 3, 4, 5, 6, 7, 8. And 224 would be what? Let's say if 128, 64, 32, 16, 8, 4, 2, 1. So 224 would be
First
this.
3 1.
First 3 will be right.
Yes, sir.
This will be 192. Then we have 32, 224. Yeah. So this is gonna be 111, and rest would be 00 because we have not used them. So what is the CIDR?
/27.
/27. So my IP block, which is 192.168.1.64/27, till what extent can I use it? How do I find that?
Sir, I guess 96.
So how did you calculate that?
So I just add 64 plus 32. 32 and 64.
Okay. So if you add 32, it will be 6. So it will be one less because you have to count this as well. So 95. Okay. Now, let's say you have prepared this, you are making your homework, and for some reason you have to validate. The calculators are always there to help you. So we will take /27. We will mention 192, 168, 1.64, enter. So where to where? See, it starts with 64, its ends at .95. These are the usable IP, 65 to 94. Is that right? 65 to 94 is the usable IP. The first IP was .67 and last IP was .95. First IP is .64 and last is 95/27. So now we will configure our routers. Okay. So let me power on this. Let me power on this. Okay, for some device it gave me, it worked, and some device it says some issues. Okay, I'll do one thing. I'll delete this and put a new node from this. We connect this. Switch on this. Yeah, now it is good. To change the icon, there is an option, change symbol. You can call it as user, circle, user. Okay. So this is my router. Let's say I have to configure the IP on this interface. Yes, who is helping me? Aditya, Lavanya, Sudhakar, Kristo. So where do I set the next IP, second IP?
Gig Ethernet 0/1.
Don't call Ethernet. It's called gig Ethernet. Okay.
Gig Ethernet. Okay, sir.
Yeah, there is a difference between Ethernet, fast Ethernet, and gig Ethernet. This is the oldest medium or transmission speed, which is like 1 to 4 Mbps something. Whereas this is 100 Mbps speed. And this is like 1000 Mbps. Okay, which is nothing but the speed of the medium. Well, okay, so let's say I have a device and I'm just injecting to that port. So this port is technically having 1 gigabit per second transmission speed. Now, but it also depends on the cable. The cable that you're using, RJ45, if you're using a Cat5 cable. So Cat5 cable are older cables. So they can only support 100 Mbps. So even though you have a powerful device, but low end cables, your transmission will only happen in 100 Mbps. So make sure you keep a better cable. So nowadays there is a Cat6 cables. Okay, Cat6, which can have speed of 1 gigabits per second. So just remember that. Okay, these are the different technology names: Ethernet, fast Ethernet, gig Ethernet. But from the initial thing or the name of this is called Ethernet. To be more precise, we call it as fast Ethernet and gig Ethernet, depending upon the speed there. Okay, so I'll go to gig 0/1. I'll say IP address. Now, which IP would I be taking?
So from 65 to 94.
Yes. I'll say 192, 168, 1 dot, let's say 70, 255, 255, 255, 192, right? It was, or sorry, it was 224, correct?
224, yes.
Yes. Then no shutdown, enter. You can also give a description. So let's say that this is a Vodafone link of 10 gigabits per second. The circuit ID is this, and it's connected to India to Australia. Enter. So come out of it, do a write mem. Now I go to this PC, which is called PC4. I'll say IP and 192.168.1 dot. Tell me some IP in that block.
So 71.
Okay, 71, 255, 255, 224, 192, 168, 1 dot 1. Is this proper?
Yes, sir.
Is this proper? Are they in the same network?
No, sir, we have to change the gateway.
Yes. By the way, what is a gateway, guys?
So it is a part of our network, like from the network which started.
See, as the name suggests, gateway. Let's say I have a PC. Okay. When I say I'm configuring a gateway, that means I'm sending it to a big brother. That means whatever this PC will not know or knows, or whatever it receives the traffic from anywhere, it will send to a gateway, depending or on relying that that gateway will know whom to send or how to send. So that gateway will now send it to the rest of the people. Okay. So for this PC, this is the gateway. Now this is now router. In some scenario, instead of routers, I can also keep a firewalls. Firewall can also act as a gateway. Okay. So let's assume that if I have multiple PC1, PC2, PC3. Now the gateway will point to one of its layer 3 device. Always remember, gateway are layer 3 device. It cannot be a switch. Even if you're using a switch, then you have to make use of a switch, which are called multi-layer switch, which act as a router as well. So these are switches which works on layer 3 in a OSI layer 3. So gateways are layer 3. So if, let's say, if it is receiving something, some data from somewhere, it doesn't know how to go out, it will send it to gateway. It goes to the gateway. Gateways are nothing but, as I told you, it can be router, it can be firewall, and they will send it to the rest of the people. But if they do not have that mentioned in their routing table, then that is dropped. Okay. So gateways are something which would know 99% about the rest of the things. So that device only we make it as a gateway. We just cannot make any random device as gateway and start forwarding it, because then it will start dropping everything, right? Okay, so now I go here. In this example, gateway was falling in a different network. So I should keep something in that block itself. So let's say if I do a .80 or something. See, technically this should be nothing but the IP of this router itself. So we have configured it as 1.70. So technically we should tell it as 1.70 because I'm sending it to that router. Router might send it to some other person, right? So that is what it says. Okay, now from here, I'll try to ping that device 192.168.1 dot. 71. See, I have the reachability. If you see the config, you see the config. You have the Vodafone link on this side, which is now reachable with the users. Okay. All right. Let's configure the last one. So the last block, let's say, starts with 192.168.1 dot. What is this IP over here? It was 95. So I'll use from 96. How many hosts does it need? It needs 5 users. So tell me which 2 to the power table will be good for me. Which is going,
29.
huh?
2 to the power 3.
2 to the power 3, 8, which can accumulate the requirement. So to figure it out, subnet mask, what I do?
So like minus 256.
How much is
Minus 8.
this? How,
250, 246. No. 248.
248, correct?
Yes.
So 255, 255, 255, 248. Okay, so once you have the subnet mask, if I try to get the CID up, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. And let's split this 128, 64, 32, 16, 8, 4, 2, 1. Okay, now add this. This is 192. We know that. This is 224. 224. If you add 224 with 16, and we might also need 8. So 32 plus 224 becomes 652. Oh, which is more. So I don't need 8. Okay, see, till here 224. Then what should I add to make it 248? If I add 224 and 16,
So it will be 240. Then we have to add 8 also.
yeah,
Till
so it will
48.
be 0, 2, 4. Yeah, this will be 240 and this will be 248, correct? So this becomes 1,
The 5
1,
ones.
1, 1, and 1. Rest I have not used, so I'll just make it 0. So now total how many it would be?
So 29.
Yeah, 24 plus 1, 2, 3, 4, 5. Yeah, it would be /29. Okay, so the block is 192.168 1.96/29 192 till what? Tell me till where it will be. 192.168 1 dot. We took 8. Okay, so let's say if it is 8. So what? How much it would be?
So 104, I guess. From 97 to 10. 104.
104. But since we are counting this, it will be.
No, sir. After not counting one, sir. Basically, it will gonna be 105. Not counting, then it will be 104. The
See,
broadcast.
this is 96, right? If you add that block of 8, which is 104, correct? Right? Just see on your paper if you're using it. See, 96 plus 8 comes to 104, not
Okay,
105.
Okay.
Right? So since we already had that IP, first IP here, So we just keeping one subtracted, which is 103. So whenever you do this, you get some doubt, you need to clarify. There is this calculator. So this you use as a backup. Okay. Don't use it as a main source. Now let's calculate. Let's say /26. My IP is 192.168.1.96. Okay, let's compare with our data. See, 96 is the first IP, and 103 is the last broadcast IP. Usable IPs are .97. Okay, usable are from 97 to 102. So now while we configure, we can take any IP from this range. Okay, now let's configure. All right, let's come here. Conf T interface gig 0/2 IP address 192.168.1.97.255.255.255.248. No shutdown. Description, let's say this is Geo, and circuit ID is this. It's a 4 Mbps. It's connected between India to Singapore. Okay. And this right mem, you see show IP int brief. These are three interface configured. Okay. These are the three configured. If you want to elaborate the config within /2, this is what you get. Now let's configure PC3 IP 192.168.1. This block is between 97 to 102. Usable IP I'm talking about. So I can use, let's say I will use 102, 255.255.255.248. The gateway is 168, 1.97 we picked. So it says good, it's configure. Now let's ping that computer 192.168.1.102. Let's give a repeat of 15 packets. See, you're successful now. Okay, so you have configured a brand new office. Floor 1, floor 2, floor 3. Floor 1 has 55 user. Floor 2 has 15 user. Floor 3 has 5 users. Without wasting, using the best practice of networking, you have utilized one single class C IP and you divided into multiple blocks. So this is the best that you can suggest if someone asks you during the interview. Okay. All right. So once this is done, now my next question is, can the PC4 ping PC3 or PC3 ping the rest of the people? Let's assume PC1, who is in the first floor, okay, who is in the first floor, can ping something on PC3, which is kept in the floor 3. Let's say 192.168.1.102. It says not reachable. But can I ping its own gateway? What is its own gateway? It's 1.25. Say it is pingable. PC1 can reach to its gateway. Okay. Can PC1 reach to some other gateway on the same device? No. Can it reach to the second gateway behind 1.25? No. So if it don't reach them, then there is very less chances that it can also reach the different users in a different network. See, for example, from PC1, if you try to ping the person who is sitting on the third floor, it will not work. So what do you think? What is happening? Why are they not reachable?
The routing to be configured.
Yes. Now they are different networks. Okay. So even if it reaches to this, okay, even if this reaches to this, might be if it is even sending the packets to the rest of the people, but they do not know how to reach back or answer back that source. So for this, we need to have routing protocol. So we have a static routing protocol and we have a dynamic routing protocol. So under dynamic routing protocol, we have RIP, EIGRP, OSPF. So from Monday, we start this topic. Okay. So today is Thursday, which is the last day of this week. I want you to do the lab, whatever we did so far, complete it, because from from the coming Monday, we are going to go into the advanced routing topic. So no more asking question on interface and basic things. So now we will focus on routing part. Okay. So you get your lab done and finish off the basic over here. Yes, Sudhakar, tell me.
Are you going to cover the VLSM?
VLSM is a variable length. This is a variable length we configured.
Oh, really? Okay.
Yeah. Whereas FLSM is nothing but when you divide them in a equal part. Say, for example, 192.168 1.0, and someone asks you to divide in a proper 4 division. Let's say in all 4 floors or 3 floors, you have equal people, 50, 50, and 50. So in that case, you will divide it in a 3 equal parts. So this is a fixed length subnetting. It's called as fixed length. Whereas VLSM is when it differs. 50 users, 10 users, 25 users, the subnet will change. Okay.
Okay.
All right, guys. So I'll wind up for here. If there is no doubt, if there is any doubt, you can let me know. We have 2 minutes.
One doubt. When we put no shutdown for an interface port, right? One
Yes.
port, and later if we are changing the IP, we don't want to do it anymore, right? Since the port is already active, we are
Yes.
just changing the IP.
We are just changing the IP.
Okay. Well, sometimes we see people are using shut and no shut after
It
they
is called
configure.
bouncing the port.
Okay.
Okay.
So, like we switch off and on the Wi-Fi in the adapter.
Correct.
Like
correct. Yes. So what
Okay.
is the reason for bounce is the shut and unshut. Why we normally do is sometimes the router on one side, as I told you, when they negotiate with the older device or something, there is chances this get into error disabled mode.
Yeah.
Okay, so when it is in an error disabled mode, the data don't get processed. So what we do, we first fix the issue and then we do shut and unshut, bouncing of port, we call it. It's basically to bring up that interface in a functional mode.
Okay.
All right, guys. So let's catch up on Monday. You practice on all the things. Okay.
Okay. Thank you.
Okay, sir.
Yeah.
Yeah.
Okay.